here we're going to look at another method for solving non-homogeneous second-order equations called variation of parameters. Before we do though, I want to start just by warming up with another example of undetermined coefficients. So let's look for the full solution to this second-order equation. And just to keep things interesting, let's add in some initial conditions. All right, so if we're looking for the full solution, we need both the homogeneous solution and the non-homogeneous solution. So let's start by finding y sub h, where we solve this homogeneous version of the equation. So as always, we'll convert this into the characteristic equation, where we get r squared plus 2r plus 2 equals 0. If we try factoring this, we're going to get frustrated pretty quickly. So let's jump straight to the quadratic formula. So that would be -2 plus or minus the square root of b squared, or 4, minus 4 times 1 times 2, all over 2 times 1. Simplifying a little bit, you get -2 over 2, or -1, plus or minus the square root of 4 minus 8 would be -4 over 2. So quickly you can tell that there's going to be a complex solution here. The first part is -1 plus or minus. Here we have the negative inside the square root. That's going to lead to the I. And then the square root of 4 is 2. Divided by 2 gives us 1. So we just have -1 plus or minus 1 times I. So we're in the third case with the homogeneous situation, the case where we have the exponential and trig combination. So in this case, our alpha is -1 and beta is 1. So in the form e to the alpha t, so we have e to the -t, times the cosine and sine of 1 times t. So e to the -t times cosine of t, and then e to the -t times sine of t. And of course, each of these gets its own coefficient. So we have our two solutions, y1 and y2, and the full y sub h is the linear combination of the two. So there's y sub h. So far, so good. The second part now is to do the undetermined coefficients problem and to find y sub p. Now, thinking ahead a little bit, when we come back to these initial conditions, we are going to use those on the final form. So we're not going to use those here to find C1 and C2. We're going to wait until we get to the final answer, y equals yh plus yp. So hold on to those for a minute, and let's find y sub p using undetermined coefficients. So the f of t over here is a combination of sine and cosine, but sine and cosine are using the same sine and cosine. So it's both sine and cosine of just t. So we can use the form y sub p equals a cosine of t plus b sine of t. And as always, then we're going to find y prime. In this case, it'd be -a sine of t plus b cosine of t. And y double prime would be -a cosine of t minus b sine of t. And then go back and plug all those in. So we have on the left-hand side y double prime plus 2y prime plus 2y. So we'll have all of this, y double prime plus 2 times y prime plus 2 times y. And all of that equals, a little more room here, all of that equals 5 cosine of t plus 5 sine of t. I guess I can't fit that on that line. All right, so again, just sort of collecting coefficients together. All the coefficients of cosine on the left have to equal 5 in total, and all the coefficients of sine have to add up to 5 as well. So picking out the cosine terms first, we've got this one here, we've got this one here with a 2 they'll be multiplied in, and we have this one here again with a 2. So together we get negative a plus 2b plus 2a equals 5. And then doing the same with the sine, we have a sine term here, a sine term here, and a sine term here. So we have negative b minus 2a plus 2b all equals 5 as well. Simplifying a little bit, we can combine some terms. So in the first case, we get a plus 2b equals 5. In the second case, we get negative 2a plus b equals 5. Again, I'll save you a little time in solving this. It's a simple one to solve. You can either use substitution or elimination, but what you should get is a equals negative 1 and b equals 3. So it turns out that our particular solution, y sub p, is negative cosine of t plus 3 sine of t. Which means we're almost done. We have the general form of our full solution. So the full solution is going to be homogeneous plus the particular added together. So that's going to be c1 e to the negative t cosine of t plus c2 e to the negative t sine of t. That was all y sub h. And then y sub p is the minus cosine of t plus 3 sine of t. So there's our full solution, and if we weren't given initial conditions, we would stop there. However, we were, so just to remind you, we were given y of 0 equals 1, y prime of 0 equals 2. So we do need to find y prime, which will be a little bit tedious because we'll have a couple of product rule pieces to work out, but let's try it. So y prime is going to equal c1 times, if we take the product rule here with this first part, the derivative of e to the negative t is going to be negative e to the negative t, and then the derivative of cosine is negative sine. So that's the first piece. If we compare that with the second piece, it's going to be very similar. So here we'll have negative e to the negative t sine of t plus e to the negative t cosine of t. Watch out for those minus signs, they can be tricky. And then the remainder will be plus sine of t plus 3 cosine of t. Now thankfully when we start plugging in 0 for y and y prime, or for t in each of those rather, things will start to simplify quickly, so this isn't as bad as it looks. So from the first condition, we have 1 equals, and then plugging in 0 for t. Now the next thing is when we plug in 0 for t, all of this goes away, and all of this goes away. So all we're left with is these two pieces. So we have c1, and also e to the negative 0 would just be 1. So we have c1 times cosine of 0, which is 1, minus cosine of 0, which is 1. So things simplify dramatically when you plug in 0, because the exponentials all turn into 1, the sines all turn into 0, and the cosines all turn into 1. So very easily we can get that c1 equals 2. Similarly with the second condition, y prime of 0 equals 2. Again, y prime looks complicated, but lots and lots of things simplify. So first of all all of the terms with sign in them go away. So that goes away, that goes away, and that goes away. And then all of the e to the t and cosines all go to 1. So it simplifies to c1 times -1 plus c2 times 1 plus 3 times 1. So again, things simplify a lot. Since we already know the value of c1, finding c2 is pretty quick. We know that c1 is 2, so we have 2 times -1. And so moving everything over, we have c2 equals 2 plus 2 minus 3. So c2 equals 1. Which means we're finally done. The whole answer looks like 2 e to the -t cosine of t plus 1 e to the -t sine of t minus cosine of t plus 3 sine of t. There's our full answer, and this example kind of threw a bunch of stuff at you, including finding not only the homogeneous and particular solutions, but also using initial conditions to find the coefficients c1 and c2. The only way this could have been harder is if the right-hand side, the f of t here, were more complicated and yp was more complicated. But really, the structure of the problem wouldn't have changed at all. It would just be the details of solving for your coefficients that would change. So the algebra can get a little more tedious and a little more difficult, but the overall principles stay pretty consistent.